microscope. Barely visible. A human hair is one of the smallest things a human eye can see. Imagine if you can shrink yourself until that hair looked as thick as your arm. If the hair looked as fat as a tree trunk. What would you see? The hair on a fly's legs would look like a monster would look like enormous spikes. The fly will look like a monster with gigantic eyes. That's the up-close view a microscope provides, and it changes how we see the world. The first simple microscope. For thousands of years, people have been interested in taking a closer look at the real world. The ancient Greeks used glass globes filled with water to make objects appear larger. In the 1st century CE, the Romans discovered that glass that was thick in the middle and thin on the edges made things appear larger. This was the first magnifying glass. People started to figure out how to make better glass lenses in Europe in the 1600s. With that discovery, the microscope was invented. At first, the microscope was just a sort of fancy magnifying glass. It had a single lens mounted above the holder of an object being viewed. Most magnifying glasses only make objects appear 5 to 10 times larger in size. That was the magnifying power of the first simple microscopes. Compound microscopes. Early microscope users figured out that they could put 2 magnifying glasses in a line with each other. The second lens magnified the image from the first lens, creating greater magnification. With this combination of 2 lenses in a single microscope, the compound microscope was born. Today, compound microscopes are magnifying objects up to 1,500 times their original size, magnified 20 to 30 times. One of the first early microscope users was Robert Hooke. Hooke improved the early compound microscopes, which was only magnifying objects about 20 to 30 times their actual size. He was also one of the first people to make detailed notes on what he saw through a microscope. Hooke published his observations in a book. In 1665, Hooke's book had drawings of close views of a louse and a flea. He drew the compound eyes on a fly in greater detail than anyone had ever seen before. Hooke also stretched sections of plants and seeds when he examined a thin section of cork under a microscope. He discovered that it was made up of tiny chambers. He described those tiny chambers as cells. Over time, the term cell became to describe the tiny building blocks of all living things. Today, examining thin slices of plants lets us see how seeds are formed and reveals how cells make up plant leaves. It shows the cells that allow water and nutrients to move in plant stems, magnifying 20 to 200 times. Historians believe that Hooke's book is better than other early magnifying users. Antony van Leeuwenhoek was a cloth merchant not a scientist. However, he used magnifying glasses to examine the different types of fabric he bought and sold. When he saw Hooke's drawing of the microscopic world, Van Leeuwenhoek started making lenses of his own. He soon discovered a way to create better lenses. As a result, he was able to make microscopes that magnified objects more than 200 times. Using these stronger microscopes, Van Leeuwenhoek discovered red blood cells. He also discovered tiny life forms called microgametes, living in lake water and then scraping in someone's teeth. Microgametes are living things too small to see with the naked eye. Before Van Leeuwenhoek's time, no one even knew they exist. Microscopes revealed that microgametes live everywhere. Today, if you use a microscope in a classroom, it probably magnifies objects about the same amount of Van Leeuwenhoek's early microscopes. Although 200 times magnification might not seem like a lot, it's enough to reveal details invisible to the naked eye. Even something as simple as sand is seen in a new light under a microscope. Without magnification, sand looks ordinary and plain. Under magnification, it's clear that sand is from ocean's edge, contains microscopic shells, coral, and volcanic rock. Magnified 200 to 1500 times. Because the lenses in the early compound microscopes were perfect, they often created changes in the image. It was hard to tell what was real and what was just an effect caused by the light passed through the lenses. In the early 1800s, a scientist named Joseph Jackson Lister invented a new type of lenses. This lens made microscopes more powerful and reliable. As a result, microscopes allowed new discoveries in science and medicine. In the mid-1800s, Louis Pasteur discovered that microgametes in the air could cause milk to spoil. Around the same time, he improved microscope allowed doctors to see microgametes in the bodies of sick people. This discovery caused huge changes in the practice of medicine. The early compound microscope also led to the discovery that no two snowflakes are alike. William Bentley was known as Snowflake. Bentley for his work with snowflakes, and he paired a camera with his microscopes in the late 1800s and the early 1900s to take photographs of more than 500 snowflakes. He showed that snowflakes are mirror images of themselves in 6 different directions. Compound microscopes also allow scientists to discover that salt, sugar, and some other things are natural from crystal structures. Salt is made up of only 2 types of regularly shaped particles. As a result, it forms crystals shaped like little cubes. Table sugar is made up of 2 different similar types of sugar. It forms crystals that are slanted at each end and longer than salt crystals. Seeing the world's tiny details can help people understand how things work. For example, the man named George de Mestral became curious about the cockleburs that stuck to his clothing and his dog's fur. He took a closer look at the birds under a microscope. He saw that they had tiny hooks and latched-on loops in the fabric of his pants. De Mestral worked to recreate the design using fabric. Years later, the result was Volcano. Volcano is made up of 2 types of fabric, one covered in thousands of tiny hooks, and the other covered in thousands of tiny loops. The hooks and loops let the two pieces of fabric zip together, magnifying 1 billion times. Because the way things work, there's a limit to how much the compound microscope can magnify things. During the past century, scientists developed microscopes that use different ways to create images, such as microscope. One such microscope uses energy called electrons. Electron microscopes provide the greatest magnification of any existing type of microscope, magnifying samples up to 1 million times. Conclusion: with each new power of magnification, more detail is revealed about the smallest structures of plants, animals, and materials. As a result, microscopes have allowed countless discoveries in nearly every field of science. Microscopes make the invisible visible, allowing us to explore the world in an entirely new way.